This particular question, if we talk about the solubility product of copper sulfide is given, calculate the maximum molarity. We will use the knowledge of equilibrium chapter here. Solubility product of this one will be copper sulfide will dissociate in Cu2 plus. And remember, this one will be solid here. It will be in solvent, aqueous solution. So it will be aqueous, and S2 minus, this will be aqueous. And you know that the solubility product here, nothing but it is actually the equilibrium constant. If you write equilibrium constant for this one, what you will write? You will say Cu2 plus, then S2 minus concentration divided by Cu solid concentration. So you will not consider this one. This will be 1 because this solid concentration will remain constant during the reaction. We will merge this one here. So we will write KSP, and I hope you have sufficient knowledge of equilibrium chapter from 11th grade. This will be the solubility product. Why this is not in the denominator? Because it is solid. We don't consider the concentrations. In this case, it is given this solubility product is 6 into 10 power minus 16. You will say, okay, it will dissociate, but another keyword here is maximum molarity. If we are talking about maximum molarity, means we are saying it gets dissociated maximum. Maximum is 100%. So if we say solubility is S, say this is S, this is S after it is dissociated. After it is dissolved, we say the solubility of both these. Obviously, it is 1:1 ratio. That's why I'm saying if it is S, this will be S, because the ratio between these two is 1:1. So KSP basically will be, if I write here, KSP will be concentration of Cu2 plus means S, and concentration of S2 minus, that is S, that is S square. So from here, I will get S equals to square root KSP, that is square root of 6 into 10 to the power minus 16. And remember, this solubility is nothing but Cu2 plus concentration. So the unit will be mole per liter, and mole per liter is actually the molarity. So this solubility is nothing but the molarity. So whatever you get, those many moles per liter will be the answer. Yes, when you solve, you will get 2.45 into 10 power minus 8. To 10 to the power minus 8 mole per liter. Any confusion here? So just you need to remember that in this particular question, you have been asked maximum solubility. If you are asked to calculate molarity, it is the solubility you are asked. Maximum molarity means 100% dissociation is there. So you don't have any amount of CUS left. 100% has dissociated. Next one. Calculate the mass percent of aspirin in acetonitrile when 6.5 gram is dissolved in 450 gram. Now this is, I don't really understand why NCERT has put as question number 28 when we have done very complex questions. This one is very simple, because if we talk about the mass percent is mass of solute, whichever we are talking about, okay, mass percent of aspirin. So you will say mass of aspirin divided by total mass of aspirin plus mass of acetonitrile into 100, because we are calculating percent. Substitute the values. So it is simply 6.5 divided by 6.5 plus 450 into 100. I think probably NCERT wanted to check whether you remember or not the concept. Otherwise, it is straightforward. So once you solve, you will get this one as 1.424%. Next one. Nalorphine, similar to morphine, is used to combat withdrawal symptoms in narcotics users. Dose of nalorphine generally given is 1.5 milligram. Okay. If it is in milligram, make sure that you convert it into grams. The calculations here are in grams. Calculate the mass of 1.5 into 10 power minus 3 m. Molality is given. Small m, lowercase m means molality is given. Aqueous solution means it is in water. Required for the above dose. So whenever you are required to calculate the mass, it means first you have to calculate the number of moles. From number of moles, obviously you can get the mass. So calculate the mass of this solution. Here basically the solution. So you don't need number of moles here, because in this particular case, what is asked? This is say solution. The question is, you need to get this whole mass of the solution, which has 1.5 milligrams nalorphine. So you have to calculate this whole mass, which has 1.5 milligram nalorphine. The molality of this is given. And if molality is given, it means you know that 1000 grams of water will have these many moles, 1.5 into 10 power minus 3. The definition of molality is number of moles of nalorphine divided by mass of water in kg. That's something you know, right? So it means you need mass, molar mass of, because number of moles here, mass is given, you have to convert it into moles. So it means you need molar mass of nalorphine. So molar mass of nalorphine will be here. If you calculate C19, so it will be 19 into 12 plus H21, 21 into 1 plus 14 plus 3 into 16. Okay, so 19 into 12, 19 10, 190 plus 38, 128 plus, sorry, 228
220
plus 21 plus 14 plus 48. So 228 plus 21, 49 plus 14, 263 plus 50, 213 minus 2, 211. So 211 you got as the molar mass of nalorphine. So now we will substitute these values. We will say the molality here is given 1.5 into 10 to the power minus 3 will be equal to number of moles of nalorphine. Number of moles of nalorphine will be
the mass is 308.
1.5 into 10 power minus 3 divided by molar mass 211 divided by mass of water in kg. Now mass of water in kg actually we need. Okay, so we will write say mass of water. I'm writing just in symbolic form. So from here you will get mass of water. So mass of water.
Sir?
Yes.
Sir, the molar mass will be 311.
311, you are right. Okay. Yes, correct. So it will be 311 because itself it was 228. So thanks for correction. And here it will be mass of water 1.5 into 10 to the power minus 3 divided by 1.5 into 10 to the power minus 3 into 211. So this is the mathematical calculation you have to do. Can anyone do this calculation for me? So just let me do the calculation. So it will be 1 divided by 211. 1.5 into 10 power minus 3, 1.5 into 10 to the power minus 3, 311, sorry, not 211, 311. mass of water. But remember this one be in kg. Okay, so mass of water 1 divided by 311, or I should divide 1000 by 311 to get directly. So okay, so this one will be, I have just used calculator, you should not be using it, 0.003215, but it will be in kilograms because in this formula it is in kg. Okay. So I would suggest that you use, you can say it is in grams and then you can have 1000 here if you want. Okay. But even this is okay. So this will be equal to 3.215 grams. Now remember, this is this the answer? Is this the answer? Tell me. 3.215 grams mass of water. Is this the answer? And I'm
No.
asking because students come to me and say this is the answer given in that book, that guide, or somewhere on internet. This is not the answer. Okay, so you might find this as the answer in book, etc. This is not the answer because the question is about calculate the mass of this aqueous solution, and solution means you are considering the water as well as the
So we
solute.
calculated for the solid.
Right. So you will add how much amount of nalorphine is there in it. So this much 1.5 milligram nalorphine is also there in this water. So that's what the question is. You need to get the mass of solution which has 1.5 milligrams of nalorphine. So you calculated this much water. If this much water is there, then nalorphine is 1.5 milligrams. So solution will be total 3.215 gram and 1.5 into 10 power minus 3 gram. This is given in milligrams, so you will convert it. So you will say hence the mass of the solution will be 3.215 grams plus 1.5 into 10 to the power minus 3 grams. So it will be actually 3.215, and 1.5 into 10 power minus 3 will be 0.0015. So it will actually be 5 and then 6, 1, 2, 3 points. So it will be 3.2165. And because the students have asked this question in previous years many times that it is done differently, I checked the answer given by NCERT also. NCERT has given its answer as 3.2, which is again not wrong, not correct. Okay. So NCERT says the answer is 3.20, which is not correct. The answer is 3.2165. NCERT answer is not correct even if you don't consider the mass of the nalorphine. Okay, even then. Any confusion here?
No, sir.
Next, calculate the amount of benzoic acid required for preparing 250 milliliters of 0.15 m solution in methanol. Whenever I said that whenever you see this type written, it means it is given number of moles. Obviously, this should be in liters. So if you convert this part into liter, you multiply by molarity, you get the number of moles here. You have to calculate the amount of benzoic acid required for preparing this solution in methanol. Now, my first question is, which one here is solute, which one is solvent? Okay, Vedant, fine. Yes, my question is, Which one is solute? Which one is solvent? Okay. Okay. Kasak, Tanishi. Right. Right. Correct, Devyansh. Almost all of you correct. Okay. So benzoic acid here is solute. Okay. It says calculate the amount of benzoic acid required for preparing 250 ml of 0.15 m solution in methanol. In methanol.
So it's asking of number of moles.
Yes. Yes. So answer can be in number of moles, answer can be in grams. Normally your answer should be in grams. Okay. But in all such questions, I always suggest you write answers as both. So because you have to calculate number of moles anyway. So when you calculate number of moles, treat that as answer and also convert that to grams. Okay. So what you will do, you will say this is, remember, molarity. Okay. So if it is molarity, means you know the number of moles of benzoic acid. Okay. So you can apply the formula. If you apply the formula, it will be like this: molarity equals to number of moles divided by volume. Okay. So molarity is given 0.15 equals to number of moles divided by volume. Volume is 0.250. I have converted this into liters. That's why 0.250. So N will be 0.15 into 0.250. Number of moles. Otherwise, you can directly multiply these two. Here also, we are actually multiplying these two to get the number of moles we got from formula. So once you get the number of moles, what you can do, you can convert it to the mass. So this is the number of moles of what? I got N equals to 0.15 into 10 to the, into 0.250. So this is the molarity given of what? This is the molarity given of benzoic acid. Okay. So if it is the molarity given of benzoic acid, you will convert this to molar, convert this to mass. So for that, you need the molar mass of benzoic acid. I have asked you to memorize few molar masses. Benzoic acid has molar mass 122. So you don't need to calculate in that case. For example, benzene has 78. Acetic acid has 60. So these things you need to remember. So benzoic acid, the molar mass of benzoic acid (122). So number of moles is given mass divided by molar mass. So mass will be number of moles into molar mass. I hope everyone is clear about these simple formulas. So just multiply. Okay, just multiply this by this. You will get the answer. The only point is where students make mistake, and that's why I asked again and again which one is the solute and which one is solvent. And where the mistake usually students do, they multiply with the molar mass of methanol because they think that methanol probably we are talking about as solute. And remember, I got few answers saying methanol is solute in chat window. Yes, Samad Pranav Sharma, correct. So when you multiply, you will get answer as, in this case, 4.575 gram. Vedant, yes. Simple question, so I'm moving forward. Now this question is very important. Basically, the underlying concept is very important, whether it is JEE, NEET or CBSE. These concepts are very important. the depression and freezing point of water observed for the same amount of acetic acid, trichloroacetic acid, and trifluoroacetic acid in increasing order, okay, are as they are. So for example, acetic acid has least, then trichloro, then trifluoro. They have depression and freezing point in that order. So minimum, then greater, here greatest depression and freezing point. How will you explain that? We will explain that on the basis of Van 't Hoff factor. So what is Van 't Hoff factor? Where does it play a role? You know that delta TF, that is depression and freezing point, is I, and then you multiply it by K, F, and M. Otherwise, it is just KFM. If Van 't Hoff factor means ionization or association is there, okay, dissociation or association is there, then you have this Van 't Hoff factor. Now, in this case, if there is greater dissociation, greater ionization, then this value of I will be greater. Why? Because I is the number of particles after dissociation. Here I am writing dissociation because this is acid, this dissociates. Then number of particles before dissociation. So if you can prove that here in this case there will be maximum ionization, your answer will be correct. Okay, and that is actually on the strength of the acid. So how will you explain that? First, understand what I am going to prove. Okay, the given statement can be proven only on the basis of this formula. This depression and freezing point will be greater if this value is greater. If I can prove that I will be greatest for trifluoroacetic acid, I will be able to prove that ionization will be maximum. So delta TF will be maximum for that. If I can show that in acetic acid, the value of I will be least. So there will be least depression and freezing point. That's what I'm saying. Okay. So how to prove that? To prove that, if I consider trifluoroacetic acid, so trifluoroacetic acid will be, acetic acid will be just CH3COOH. Okay, this will be acetic acid. Now, if I replace all these fluorines, hydrogens by fluorine, so now this is trifluoroacetic acid. Instead of CH3, it is now CF3COOH. And similarly, if I replace all the hydrogens by chlorine, it is trichloroacetic acid. So how do I define the acidic character? I define it on the basis of electron withdrawing group or electron donating group, if few of you can recall from your 11th grade. Okay, fluorine is strong electron withdrawing group, highly electronegative, the most electronegative element in periodic table. So this will pull the electron density towards itself. So this will pull electron density. All these three will pull electron density from this carbon. Carbon in turn pulls the electron density towards itself. And hence here, this hydrogen becomes more electropositive because it has lost electron. The electrons are pulled by fluorines. So now this is more electropositive. In this case, it is most electropositive. 3 fluorines here. So the hydrogen in this case will become most electropositive. And hence, can OH bond becomes ionic. OH bond becomes ionic. Now it can be broken easily in solution form only. Remember, I'm not talking about solid form. In solid form, if I say NaCl, NaCl is very hard, but The moment you dissolve it in water, the moment you put it in water, it gets dissolved. Why? Because the ions are separated. Same thing happens here. If there is greater difference in electronegativities between oxygen and hydrogen, hydrogen is now very electropositive, ionic character in solution, it will get ionized very easily. So you will say, due to the electron withdrawing nature of 3 fluorines, the electron density on this hydrogen will decrease significantly and it will be most electropositive. And hence OH bond will break very easily in the solution and we will get greater number of ions. Greater ionization will be there. And if it is greater ionization, the number of particles after dissociation will be greater. Numerator part here will be greater. In this case, similar thing will happen, similar phenomenon, but chlorine is not as a strong electron withdrawing element as fluorine. So here, yes, hydrogen will be electropositive. So you will say hydrogen is more electropositive. And hence, there will be greater ionization, not as much as in case of trifluoroacetic acid, but here there will be greater ionization. In CH3COOH, hydrogens are there. So here, these are the hydrogens. And hydrogens are normally considered as neither electron withdrawing nor electron donating. So here, whatever you have, you will consider that much electropositivity. So here, the normal electropositive, in case of this one, trichloro, more electropositive, so ionization will increase. In case of trifluoro, most electropositive amongst these 3, so maximum ionization. So it means in case of trifluoroacetic acid, the number of particles after dissociation will be maximum. So in this case, there will be maximum I. Okay. I will be maximum. Van 't Hoff factor will be maximum. And here in this case, I will be minimum. And hence by this formula and by this formula, delta TF will be minimum here. And in this case, delta TF will be maximum. So understand the reason. Try to link all the statements, what I have said. I'm giving you 30 seconds to recall everything, to join all the bits, whether you are able to write the answer or not. If everything is clear, I will move forward. But remember, I am slightly worried if you are not good at finding out these type of answer for these type of questions. Increasing, decreasing order, very common questions in JEE main.
Sir,
Yes.
sir, near the I, sir, you have written most electropositive, and OH becomes ion.
Ionic. OH bond becomes ionic. This OH bond becomes ionic because suppose you have O and H here, and suppose this has remember, this is electronegative, already electronegative, this is electropositive element, right? So here what happens if you pull the electron density from here, this oxygen pulls the electron density from hydrogen. So I'm giving you an example. Suppose initially the electronegativity here, electrons here were, say, I'm just using any unit 4. Okay. Here there were 2. And suppose what happened that due to something, this pulled -1. This pulled 1 in this direction. So how many are there here now? 3. Here there are still 2. But because it has lost electrons, what it will do, once one is there, it will pull the electron from here, one electron from hydrogen. Say, I'm just using, some hypothetical values. So again, now here it has 4 because it has received from hydrogen 1, but now hydrogen has only 1 electron. So 1 electron means less electronegativity. Less electronegativity means more electropositivity. Electrons are negative. So 2 electrons means more negative, 1 electron means less negative. Less negative means more electropositive. So initially, if there was delta plus charge, now there will be 2 delta plus charge, for example. Is that clear, Anand, what I am saying? So
Yes.
only hydrogen which has lost the electron effectively, not the oxygen, because oxygen lost it, but oxygen gained.
So it is based on H bonding.
No, it is not hydrogen bonding. Hydrogen bonding is not covalent bond. Hydrogen bonding is just force of attraction between electronegative and electropositive elements. There is no covalent bond there.
Okay.
Okay. So this is normal covalent bond I am talking about, which is already there. But now it becomes ionic because the difference in electronegativity is greater. Here it was 4 minus 2, 2. Here it is 4 minus 1, 3. So the difference in electronegativity is greater, more ionic. Next question, calculate the depression and freezing point of water when 10 grams of CH3, CH2, CHCl, COH, that is 2-chlorobutanoic acid, is added 250 grams of water. Question is slightly lengthy, so everyone will pay attention here. What I am saying, that is, we have talked about it earlier also. If you see there is Ka given, it means it is not 100% dissociation. It means there will be some Van 't Hoff factor. So Ka means 100% dissociation is not there. There will be some Van 't Hoff factor. How do we get that Van 't Hoff factor? Based on that, yes, we can calculate the depression and freezing point, because otherwise depression and freezing point will be very straightforward. It will be Kf into m. But here we have to calculate the value of I. It will be I into Kf into m. Kf is the freezing point constant and m is molality. You know that. Okay. So how to get that? It means first we need molality. Kf is given. We need molality and we need I. And for I, we need the reaction. Basically, how the ionization will take place. Only the ionization. Okay. So for molality, it is straightforward because we have 10 grams of 2-chlorobutanoic acid in 250 grams of water. So it is straightforward. This is in grams, solvent also given in grams. So M will be number of moles, means 10 divided by, for that you will have to calculate the molar mass also. So first calculate molar mass. Molar mass of CH3, CH2, CHCl, COOH will be CH3, remember, is 15, CH2 is 14. Okay, so it will be 15 plus 14 plus CH will be 13 plus 35.5 plus again C12 plus 2 oxygens, 32 plus 1 hydrogen. 1. Okay. So we will have 2 and so 15 plus 13, 28 plus 14, okay, 42, 42 plus 12, 54, 54 plus 2, 56 plus 30, 86, 87 plus 35, 87 plus 35 and 22. Yes, 0.5. Okay, so many answers I had already received. Kasak, Tanishi, good. Okay, I didn't see that. Okay, so it will be 122.5 grams per mole, the molar mass. From here, we will calculate the molality. You may not calculate molality. You can directly substitute it here. You can just calculate the value of I, because molality will be the number of moles. Number of moles will be given mass divided by the molar mass. So you can submit it later on. Sorry, substitute it later on also. But how do we calculate the value of I? To calculate the value of I, you will write the dissociation. So you will say, okay, CH3, CH2, CHCl, COOH will get dissociated in CH3, CH2, CHCl, COO minus plus H plus. This will be the case. So if initially this is C, this will be 0, this will be 0. So total number of moles initially will be C plus 0 means total. I am writing here total 0. No, sorry, C. Why I am calculating it? Because the I, Van 't Hoff factor, will be the number of moles after dissociation divided by number of moles before dissociation. So before dissociation, I have C. After, or you can say final, it will be C minus C alpha. I hope you remember, if we assume alpha is the degree of dissociation, then it will be C minus C alpha, and this will be C alpha, this will be C alpha, because the ratio is 1:1:1. So if C alpha is consumed here, C alpha will be produced, C alpha will be produced, 1:1:1. So what is the total number of moles? Total number of moles, you add all these, C alpha got cancelled, C plus C alpha. This is the total number of moles after dissociation. Anyone, any confusion? Ask at this point. Otherwise, when I am done with the whole question, it will be difficult to repeat everything. Remember what I am doing? I am calculating the value of I. I have to use this formula. Molality I can calculate very easily. Number of moles given mass divided by molar mass divided by mass of water in kilograms. So I will divide by this, that is 0.250. So I will get M. Kf is given. The only thing unknown is I. That is what I am calculating. I is actually the number of particles or number of moles, you can say, after dissociation divided by number of moles before dissociation. But if you get I right now, you will get that in terms of alpha. So it means you need to get alpha first. Alpha you will get from Ka. Because for this one, Ka is of the order of 10 power minus 3. So tell me whether I can neglect, I can do approximation or not.
Yes, sir. We can do approximation.
Right? We can do, because it is of 10 power minus 3 or less, we can do approximation. So instead of writing Ka equals to here C alpha dot C alpha divided by C, here this is C1 minus alpha. So whether you write C minus C alpha or you write C 1 minus alpha. So C and C got cancelled. You might say it is C alpha square divided by 1 minus alpha, because, but this one is very, very small. We will neglect this in the numerator denominator. So it will be just C alpha square. You don't need to write this much. You will just say Ka is C alpha square. Because Ka is very small, we can do approximation. From here, alpha will be square root Ka by C. Right? Now there is one point probably which is you have to do. Anyway, you will have to calculate molality. Why? Because you don't know C. C will be given by molality. Again, approximation you can do. Molarity will be approximately same, because K is very low. So you will have to calculate molality first. That will give you the value of C. Otherwise, you will not be able to calculate. So initially I said you can substitute the values at the later stage, but you have to do it right now. So molality will be equal to number of moles, that is given mass divided by molar mass, divided by mass of solvent in kg, 0.250. Okay. Let me calculate. 10 divided by 122.5 divided by 0.25. Okay, so it will be 0.326530. So 0.3265, I would say 0.3265 m. This will be the concentration. Okay, this will be the concentration approximately. Why I am saying? Because it is of the order of 10 power minus 3. If K is of the order of 10 power minus 3 or less, these will be approximately same. So you will say C will also be 0.3265. So here I'm writing it just separately. So hence C is 0.3265, so that you can remember. And now remember, here the unit is M, that is moles per kg. Here it will be mole per liter. I am doing approximation here. So I will substitute that value here now. Square root of Ka, which is 1.4 into 10 to the power minus 3, divided by C, which is 0.3265. So as I said, question is slightly lengthy, so you should note down all these things. Then you will do calculation of this one. Just let me do the calculation. 1.4 divided by 326.5, I can say 326.5 directly. Then square. Approximately it will be 0.065. So when you solve, it will be 0.65 approximately. So you got the value of alpha from here. Alpha is degree of dissociation. Once you have got the value of alpha, okay, so alpha you got 0.65. Once you got the value of alpha, you can calculate I. And what will be I? I will be number of moles after dissociation divided by number of moles before dissociation. So I will be C 1 plus alpha divided by C. That is, I will be equal to 1 plus alpha. I equals to 1 plus alpha simply. It means I will be equal to 1 plus 0.65. That is 1. No, it will be, I have written here 0.65. It will be 0.065. Okay. 0.65. That is 1.065. Now you can use all the values to get the answer, delta TF. So now you will say hence delta TF will be I KFM. I will be 1.065. KF is given 1.86. Even if it is not given, you should know it, 1.86. And M you have already calculated 0.3265. And when you calculate, I have the answer written here as, you should get it as 0.647, approximately 0.65 Kelvin. Understand all the steps from where I started. Read the question carefully. Most of the times students are not able to recall because they don't read the question, they just read the answer. Understand the question first, then recall the answer. I'm giving you 15 seconds. Okay, yes, Sharma, are you there? Yes, Sharma. Mark your presence in the chat box. Everyone, mark your presence in the chat box. Okay, Yash Sharma, my question is, unmute your mic. My question is, just repeat the process what we have done, not the calculations, just the steps. You know, and if you know, have done programming, just the algorithm. I'm not interested in coding. Tell me the algorithm. Is your mic not working? Yes, Sharma. No, you need to get it sorted out. Okay. I'll speak to your father today. You should be able to answer the question on mic. Okay. Yes, Vedant, unmute your mic. Tell me what were the steps there. Vedant, unmute your mic.
Sir, am I audible?
Yes, you are.
So first we found the molar mass that is Cl. Then we use the formula of degree of association.
But that is, that is not complete. I'm looking for something else also. Ananya, unmute your mic. Tell me the procedure, tell me the steps you have followed here. Ananya, am I audible or not?
Yes, sir, you are.
So what were the steps we talked about in previous question?
Sir, we talked about first taking out the molar mass, then after that taking out the we took out the degree of dissociation.
Ananya, when I started the question, I said, first we will talk about what we have to use. We use the formula delta TF equals to I KF M. For that, you will decide what you need, how do you calculate that. And that is the approach all the time you will follow. You will not start with, okay, we will calculate molar mass. Okay, we should calculate the ionization constant. No. You will first see what is actually the formula which will give you the answer. Then you will see what are the unknowns in that formula which you need to get. So in that formula, delta TF equals to I KFM, molality was unknown, and then I was unknown. And that's why we followed this process. If you don't do like this, you will not be able to get the answer of any different numerical. Ananya, is that clear?
Yes, sir.
So in this case, I said, because we will be using this formula, we can get the answer from this. We have to calculate the depression in freezing point, and because Ka is given, it means I will be there, but I is unknown, M is unknown. We calculated M, and M was required as C in the calculation of I also. Once we got these values, we substituted, got the answer. Next one. Last question of this session, and then we have class at 7:15. Okay, might be if I have time, I can do one more question. Okay, 19.5 grams of CH2FCOH is dissolved in 500 grams of water. The depression in the freezing point of water observed is 1 degree Celsius. Okay, observed means, Devyansh, observed means
calculate.
Yash Sharma, observed means Prakriti, correct. Prakriti has given me correct answer. Okay, write the answer in chat box. Observed means when it is observed, okay, Kasak, yes. Okay, Tanishi, yes. No, Vedant. Yes, Tamad. Devyansh, no. Okay. So when we say it is observed means we are doing experiment. Observed means we are doing experiment. This is experimental value. Calculate the Van't Hoff factor and dissociation constant of fluoroacetic acid. Question is not tough. It is very, very easy, but yes, it might be slightly lengthy. So observed value is given 1. You can get the value of Van't Hoff factor if you know the calculated value. Observed value is there. If you know the calculated value, you can get Van't Hoff factor. Okay. So you have to calculate the Van't Hoff factor, which is easy. Then you need to calculate dissociation constant of fluoroacetic acid, means Ka, which is again you will use with the same formula which we have used earlier also. So question is not tough. Okay. So what we will do, we will we have 19.5 gram dissolved in this one. So it means we need molar mass of this one. So molar mass of CH2FCOOH will be 12 plus 2 plus fluorine will be 9 plus carbon 12. No, fluorine I have written atomic number there. Okay. 19, it is 19 plus again 12 plus 2 oxygens plus 1. 14 plus 19, 33 plus 12, 45 plus 146 plus 30, 26 plus 1, 76 plus 1. 1, but it should be even number because here I have 9, here I have 1. Where did I
Sir,
make
it is 80.
80. 12 plus 2, 14 plus 19, 33 plus 12, 45 plus 1, 46 plus 30, 76 plus 2, 78. It should 78. Just check again. Okay. If it is 80, tell me. So molar mass we got from here. So moles we can get number of moles of CH2FCOOH will be given mass divided by molar mass. Okay. Correct. Then we have to calculate the Van't Hoff factor. For Van't Hoff factor, we will need to calculate here. It is, remember, it is delta TF when it is observed. Okay. So if I say dash, okay. So delta TF or say delta TF will be I KF into M from here. So I can calculate I from here. Either you use the observed value divided by calculated value, remember? So you can calculate first this one. So remember what I am saying, it can be expressed in 2 terms. It is same thing what I am doing. Either you can use this formula or you can say delta TF dash is equal to I delta TF, because this is actually delta TF. From here you get I equals to this delta TF dash is observed value. This delta TF is calculated value. So same thing. Okay. But I suggest you use this formula when it is required, when it is given in that form. Here you should not get confused and you should use the formula directly to get the value of I. You can use this directly. If there is any confusion, just let me know. Okay. So you got the number of moles. Why I am getting the number of moles? Because I need molality. Okay, I need molality. So I will say, okay, this delta TF, this depression is 1. So I will write 1 equals to I into KF. KF is 1.86. You should remember. And then you will calculate the molality. Molality will be this number of moles. That is 19.5 divided by 78. Just confirm whether this is 78 or 80. Meanwhile, divided by the mass of water in kilograms. So from here you will get the value of I. I will be 0.500 divided by 1.86 into 19.5 and in the numerator 78. So when you calculate, you will get the value, just a second, 0.5 multiplied by 78 divided by 1.86 divided by 19.5. You will get 1.075268. So approximation you will have to do 1.075226. You can write 3. Okay. So that is the value of I you got, and this was one asked. Okay, Van 't Hoff factor you have obtained. Now you have to obtain dissociation constant of fluoroacetic acid. For that you need to write the reaction. Okay, for that you have to write the reaction. So it will be CH3FCOOH will get dissociated into CH3FCOO minus and H plus. So initially I'm doing the same thing. Okay, so it is revision for you. It is C, this is 0, 0, total C, and finally this will be C minus C alpha, C alpha, C alpha. So total will be C plus C alpha. Okay, and what is C? C is molality. C is molality. I have not calculated molality separately because I remember I have substituted the value there, but I can calculate this value. Okay, so I will be here. I will be C plus C alpha, the number of moles after dissociation divided by number of moles before dissociation. So again, it is C plus alpha. So from here, alpha will be I minus 1. And I think I was 1.07 something, 053 probably, minus 1. So alpha will be 0.05753. Everyone clear about it or not? What I am talking about? Why I need alpha? I need alpha because I have to calculate Ka. Ka is C alpha square. For that, in the question it is asked to calculate Ka. So alpha I got from I, but C is still required. C is molality. C is molality. So in all such questions, you will consider C as molality. So how to calculate molality? Molality will be number of moles, and in this question, I think it was 19.5 grams, and we calculated given mass divided by molar mass, and it was 0.500 in water. Okay, so this will be the molality. Alpha is degree of dissociation, Tanishi. Degree of dissociation. Okay. Degree of dissociation. We got alpha. Why we are calculating alpha? Because we need it in the value of calculation of Ka. That's why. Okay. C we got it from here. C is equal to molality. Number of moles divided by mass of water in kilogram. Okay, number of moles given mass divided by molar mass divided by mass of water in kilograms, and I'm just doing calculation. Give me a few seconds. 19.5 divided by 78 divided by 0.5. It is giving me exactly 0.5. If that is so, very good.
Yes, sir.
Yeah. I'm writing C as 0.5. We have calculated. Now we need to get the value here of Ka. I will not write Ka as C alpha square. Rather, I will get Ka as this concentration divided by this concentration. So Ka will be concentration of CH3FCOO multiplied with concentration of H-ion, products concentration raised to their stoichiometric coefficient divided by reactants concentration raised to their stoichiometric coefficient, means C alpha multiplied with C alpha divided by C minus C alpha. So it means it will be C square alpha square divided by C1 minus alpha. C and C1 got cancelled. So it will be C alpha square divided by 1 minus alpha. This is something we have done in 11th equilibrium chapter as well. I am just doing it very quickly, but if you are still facing problem in such cases, do all the steps. Okay. So C alpha square divided by 1 minus alpha, you will substitute all the values and then you will get the answer. So when you substitute all these values, have Ka equals to C into alpha square will be 0.0753 whole square divided by 1 minus alpha 0.0753. The reason I am not neglecting it, because if I'm doing 1 minus 0.753, it is not negligible. Okay, that is another reason why I am not doing the approximation. Now let me calculate again. So it will be 0.0753 whole square into 0.5 divided by 1 minus 0.753, it will be 0.927. So it will be approximately 3.0659, or you can say 3.066 into 10 to the power minus 3. That will be the answer.